Good day, everyone. Today's topic is all about forces. Our layman's definition of force is that it can be described as a push, pull, or lift. So, doing this action, push, pull, lift, means force is exerted. However, our scientific perspective of force is that it is an interaction between mass together with acceleration. So these are the two factors that affect force. If one would like to increase or decrease force, you can simply change the mass or change the acceleration, or you can even change both the mass and acceleration. Combining these two quantities, you'll be able to determine how much force is present in the object. You can quantify force using mass and acceleration concept. The formula for force, represented by capital F, is equal to mass, small m, times the acceleration. So force is a product of mass and acceleration. The unit of force is equal to capital N, which is named after Sir Isaac Newton. 1 Newton, 2 Newton, these are the quantities that describe forces. Forces can also be represented by an arrow. The arrowhead determines the direction of force, while the length of the arrow or the body of the arrow suggests the strength or the magnitude of the force. When a quantity is being described both in magnitude and in direction, this quantity now is called a vector quantity, meaning force is an example of a vector quantity. To understand better forces, we will use the method called force diagram, also known as your free body diagram. So we'll be using a diagram to be able to determine the forces acting on the object. By doing so, we can conclude or we can identify whether or not the forces will result to motion or the forces can lead the object to motion. More of this will be discussed in the next chapter of our video presentation. This time, we will now use the free body diagram to analyze the situation and to determine the forces acting on the object. Case number 1, we have a food on the table. So we will now going to represent that food or that object with this box. And that line represents the table. So what are the forces acting on the food? As we all know, if we remove the table from this context, the food will just fall to the ground. That is because of a force acting on it downward. And that force acting downward is called the force of gravity. But what is the reason why the food is resting or the food is stationary on top of the table? Because there is an equal but opposite force that counteracts gravity. And that force is supplied by the table on the food, which is called the normal force. Now, for it to stay at rest, that means both the gravitational force and your normal force are equal but in opposite direction. Scenario number 2, a customer pushing a shopping cart. So here we are again going to represent that cart with a box, and you have the surface. So the customer is pushing the cart. So as a result, that cart starts to move. So we will now identify that effort uh, brought by, or the effort given by the customer. So that force is called the applied force. And the shopping cart, there is also a force produced by the shopping cart and that of the floor. Yes, that is correct. And that is called the frictional force. However, shopping carts are installed with wheels. The primary purpose of wheels is that they minimize friction. So in this case, frictional force is lesser than that of the applied force. So common sense will tell us that the cart will move following the direction of the bigger force. And in this case, that is the shopping cart. In this case, that is the applied force of the customer. Third scenario, a falling fruit. So you have here, again, that is represented by that box there, a falling fruit. So we know that when a fruit fell, the speed or the velocity is increasing. It gets faster and faster as it falls. That is because of gravitational force, or the force of gravity. And that gravitational force is bigger compared to the normal force. And that is the reason why it will continue to accelerate before it lands on the ground. Next and final scenario. A parachute descends at a constant velocity. Unlike the third one here, the parachute descends or goes down at a constant velocity. Here, a falling fruit is descending in increasing velocity, while here it is moving at constant velocity. So what are the forces acting on it? Are there forces acting on the object when it's moving at constant velocity? So we are going to analyze it here. So we know that force of gravity is acting, is acting it downward. So that's force of gravity. But since the object is moving at constant velocity, that means then the normal force is as equal but opposite in direction with the force of gravity. Thus, it allows the parachute to descend without changing the rate of fall. It is moving at constant velocity. So, what is common between these scenarios here? All of these forces come in pairs. Yes, forces come in pairs. When one force is absent, or when one is absent, then there is no force exerted because forces come in pairs.